Hello and welcome to Robu. Today we are going to make sound reactive LED lights. And for that we are going to use this LED strip. Now LED strips are a popular lighting solution for a variety of applications. They are used in creating ambience in the room, enhancing the ambience in the room, creating additional lighting in photography, and do attractive lightings in festivals. But this is not a normal LED strip. This is WS2812B. This is programmable LED strip. And we can program any pattern on this LED strip. We can program any pattern on this LED strip. We can individually control the LED. We can set the color, brightness. So let's program this LED strip, and for that we are going to use this RPi Pico. But this RPi Pico cannot deliver this much current to power all this LED strip. So we require this adapter, which is of high ampere, which is of 3 ampere. So it's enough to power this LED strip of 60 LEDs. So this adapter, will plug like this. So ground and VCC will go to this LED strip. This data pin and ground will go to the RPi Pico. Circuit diagram of this is given in the blog. Link is given in the description. Click on that link, and now let's start programming. So before writing the code, we need to install library for this LED strip. So the library link is given in the description. After extracting the zip contents, you will get 2 Python files. You need to upload that to RPi Pico. The installation steps are given in the blog. Read the blog, and now let's start typing the code. So let's start writing the code. So input pin and ADC for the LED strip data pin and the microphone. Now I'll import a NeoPixel library. From NeoPixel, import NeoPixel with N capital. Now I'll import time, give delay. Now I'll create a pixel object called pix, NeoPixel object. So this is a NeoPixel class, and it takes an argument. So first argument is the number of LEDs we have in our strip, which is 60 LEDs. The second is the machine state number, which is 0. The next one is the GPIO pin on which you have connected the data pin. So I've connected GPIO 0 to the data pin. And the last argument is the color format, which is GRB. So I'm using the combinations of green, red and blue to create the colors. So I already created a dictionary of different tuples of different RGB values. So here color dict is the name of the dictionary, and 0 represents yellow color, which is comprises of red maximum and green 100. So the combination will make a yellow color. In similar way, I have made 6 such colors. You can make many more colors according to your application. So now let's use a library function called fill. So I will use pix.fill to fill the LED strip with yellow color, which is the first color of our dictionary. So I'll write color dict. In the square brackets, I'll use 0, which means it's the first color. First, we have to set the brightness. So pix.brightness will set the brightness of the LED. So 255 is maximum and 0 is minimum. And then we have to write pix.show, which will update the colors to all the LEDs. Now I run this code. Missing G in brightness. Now run this code. You can see that all the LEDs are lit up. You can see all the 60 LEDs are on with the color yellow. So in similar way, there is one more function called set line, set pixel line. So what this function does is, suppose you want only this top 10 LEDs to be on from 40 to 59. So the top LED is 59, the first LED is 0. And in this way, we have total 60 LEDs in this strip. Suppose we want only the from 40 to 59. So how can we do it? By using this function. So we enter the first LED, which is 40, and the last LED, which is 59. And the last argument is the color dict, which is the color that we want to LED to glow. Now we run this code and you can see that only the LEDs from 40 to 59 are on. Rest all are off. In similar way, there is one more function called line gradient. Pix.setLine gradient. So I'll just put one more word here, gradient, and it takes two colors. So total it takes 4 arguments. So I add one more color here, which is green from the color dictionary. So color dict I will put here 2. So 2 is green, I know. So when I run this code, you can see that there is a gradient effect from yellow to green. So if you want this effect, you can use this function pix.setPixLine gradient. So these were the functions. Now let's create some animations. For this I will use for loop. So for I in range, so I'll loop through all the colors in the dictionary. 0 to 7 will cover all the 6 colors. And then I will use just fill because I want all the LEDs to be lit up. And there is only one color. So the colors will be picked depending on the for loop variable. So right here I. And after pix.show, I will give some time delay of 500 milliseconds. So each color will be wait for 500 milliseconds. So you can see that each LED is now glowing, LED strip is now glowing with each color after 500 milliseconds. So if you want this to be continuous, you have to use while loop. Start this code. So you can see now we are looping through all the colors in the dictionary. So it starts from yellow, orange, green, blue, red, sea blue, white. So in this way, so suppose now we want a fading effect, like fading on and off. So for that we need to add one more for loop. And which will go from the maximum brightness, which is 255, to minimum, which is 0, in steps of -5. And instead of this 255, we write here a variable, which is the brightness. I run this code again and we'll change the delay to 2 milliseconds. Now you can see the LEDs strobe with different colors. They turn on and they gradually turn off, like fading off. So this fading off effect is achieved. But if you want it to activate on sound, so what can we do? So already we have imported the ADC. Now I have to define the pin on which I attach the mic. So we have connected mic on pin 26, which is ADC 0. So I write that 26, and then in the while true, I will read that ADC pin and store it in a variable called mic val. So mic val is equal to mic.read underscore u16, and I print that variable mic val. And if the value of mic val is greater than 65535, less than 65535, then we know that the sound is detected. So I will write mic val is less than 65535. And instead of this for loop, first for loop, what we want is every time we make sound, the count should increment. So I will take a count variable C here and I'll give it initially 0. And whenever the sound is detected, I want the count to increment. So I write C plus equals 1. And the count will determine the color of the strip. So instead of I here, I will write here C. So every time we make sound, what will happen? That color will stroke and gradually turn off. So I will run this code. So right now you can see that yellow is on, but as soon as I make sound, it will gradually turn off. So every time I make sound, the color is changed and gradually it turns off. So it is a good tool in theaters, in party halls. You can use this system. So every time I make sound, the LED turns on and gradually turns off. So in this way, we can detect the sound and turn on the LEDs. In similar way, I have one more code which creates a shooting star-like effect. And for that, I have used set pixel line. And it starts from the first 5 and rolls down all the way to the 60 LEDs. So I run this code. We can disconnect the ARPA and connect it again. Now I will run this code shooting star effect. Every time I make sound, you can see that it creates that color and it creates a shooting star-like effect. So in this way, you can create this effect, and you can see for that I have used a for loop which goes from 0 to the last LED, and the step size is variable. So we can change the speed. For example, suppose I set here 4, and the speed will be reduced. I will stop this code, run this again. See, the speed is lowered. So in this way, you can also set the speed by changing the step size. So initially I set the brightness to maximum, then I read the mic val and I flash the same color. Then I run a for loop which goes from the first 5 to the last 5. And why I've used this CMOD 7? Because I don't want the count to exceed above 6. So at 6, it again rolls to 0, 1, 2, 3, 4, 5, 6. Again, it starts from 0. So in this way, we are confined to only 6 colors. You can use as many as colors you want. And the last, I fill the LED strip with black color. There's nothing but all LEDs are off. So this effect, all LEDs are off naturally. But when we make sound, the LEDs are on. So in this way, it creates a beautiful effect. If you want to create this project, link is given in the description. You can go through the blog. So this was the project. If you found this project useful, let us know. Like this video. And if you have your own ideas regarding this LED strip, how you can use it in your field to create amazing LED arts, let us know in the comments. Subscribe to Robu for more amazing content. Until next time, stay tuned with Robu.